Good evening, everyone. I welcome you all in this freshman course in mathematics for natural science. This video is about logical connectives. A logical connective is a symbol used to connect two or more propositions. There are basically five types of logical connectives: conjunction, disjunction, negation, implication or conditional, bi-implication or biconditional. So let's start with conjunction logic. If two propositions P and Q are joined with the connective end, then the proposition formed is called a logical conjunction, and it is denoted by this symbol, and it is read as P and Q or P conjunction Q. For example, we have a proposition P, that is Albert Einstein was a scientist, and another proposition Q is Albert Einstein developed the theory of relativity. So their conjunction will be P and Q, which refers Albert Einstein was a scientist and he developed the theory of relativity. Here we have two propositions P and Q, so we have four possible combinations. Either P and Q both are true, P is true, Q is false, or P is false, Q is true, or both P and Q are false. So here we will discuss all cases one by one. So let us consider case 1 when both propositions P and Q are true. Let's take the propositions P and Q as 12 is an even number, which is a true proposition, and even numbers are divisible by 2, which is also a true proposition. Now their conjunction is given by P and Q as 12 is an even number and even numbers are divisible by 2, which is also a true proposition. Hence, the conjunction of P and Q is true if P and Q both are true. In second case, we consider P is true but Q is false. Here P is 7 is a prime number, which is a true proposition, and Q is 7 is divisible by 2, which is a false proposition. So their conjunction is P and Q as 7 is a prime number and divisible by 2, which is a false proposition. So the conjunction P and Q is false if P is true and Q is false. In case 3, we consider P is false but Q is true. Here we take P as 3 is an even number, which is a false proposition, and Q, even numbers are multiplication of 2, which is a true proposition. When we combine these P and Q, we have 3 is an even number and even numbers are multiplication of 2, which is a false proposition. So the conjunction P and Q is false if P is false and Q is true. In the next case, we consider P and Q both are false. Here P is 13 is an even number, that is a false proposition, and proposition Q is 13 is divisible by 2, which is also a false proposition. By applying conjunction logic, we have 13 is an even number and divisible by 2, which is again a false proposition. So the conjunction of P and Q is false if P and Q both are false. So we can say that the conjunction of P and Q is true if both P and Q are true. This is the truth table of conjunction logic. We can find the truth table using another method. As we know that the mathematical value of true proposition is 1 and false proposition is 0, here we define this symbol as the multiplication. So we have, if P and Q both are true, so 1 times 1 is 1 and 1 refers true. True times false. means 1 times 0 is 0, which refers false. Similarly, false times true, 0 times 1, which is 0, so resultant is false. Similarly here, 0 times 0, which is 0, so resultant is false. Now, the second logical connective, that is disjunction. If two propositions P and Q are joined with the connective OR, then the proposition formed is called logical disjunction and is denoted by P or Q. We read it as P or Q or P disjunction Q. For example, let P be a proposition 24 is an even number, and Q another proposition 24 is divisible by 6. Then the disjunction of P and Q is given by 24 is an even number or divisible by 6. Again here we will consider 4 cases. In the first case, both P and Q are true. For example, P is 12 is an even number and Q even numbers are divisible by 2. Here both propositions P and Q are true. So their disjunction is given by 12 is an even number or even numbers are divisible by 2, which is a true proposition. So we can say that the disjunction of P and Q is true if P and Q both are true. In the second case, we consider P is true but Q is false. So here we consider the proposition P as 7 is a prime number, which is a true proposition, and Q is 7 is divisible by 2, which is a false proposition. So their disjunction is given by 7 is a prime number or 7 is divisible by 2, which is again a true proposition. So we can say that the disjunction of P and Q is true if P is true and Q is false. In the third case, we consider P is false but Q is true. Here P is 3 is an even number, which is a false proposition, and proposition Q is even numbers are multiplication of 2, which is the true proposition. So their disjunction is 3 is an even number or even numbers are multiplication of 2, which is a true proposition. So the disjunction of P and Q is true if P is false and Q is true. In the fourth case, we consider both P and Q are false. Here P is 13 is an even number, which is a false proposition, and proposition Q is 13 is divisible by 2, which is also a false proposition. So the disjunction is 13 is an even number or 13 is divisible by 2 is a false proposition. So the disjunction of P and Q will be false if P and Q are false. So one point we have to remember, the disjunction of P and Q is true if P and Q both are true. This is the truth table of disjunction logic. Here the disjunction is false if both P and Q are false. Another method to find the truth table of disjunction logic is, here we assume this symbol OR as addition. So we have, if P and Q both are true, it means 1 plus 1. 1 plus 1 means that is not a false proposition. 1 plus 1 cannot be 0. So we have a true proposition. True plus false means 1 plus 0, which is 1, hence we have the resultant is true. 0 plus 1 equals to 1, resultant is true. 0 plus 0 equals to 0, resultant is false. Next connective is negation. Suppose P be any proposition, then negative of P is called negation of P, and it is denoted as this symbol, either by this symbol or this symbol. This is called negation of P. If P is true, then its negation is false, and if P is false, then its negation is true. For example, P be a proposition, football is the most popular sport in Ethiopia, which is a true proposition. So its negation will be football is not the most popular sport in Ethiopia, and its truth value will be false. Let's take another example. 17 is an odd number, which is false. So its negation will be 17 is an odd number, which is true. The truth table of negation logic is if P is true, its negation will be false. If P is false, its negation will be true. The third connective is implication or conditional. If two propositions P and Q are joined with the connective implies, then the proposition form is called a logical implication and is denoted by P implies Q. Means if P, then Q. Here P is called hypothesis and Q is called conclusion. Let's take the first case when both propositions P and Q are true. Suppose P is 12 is an even number, which is a true proposition, and Q, even numbers are divisible by 2. Here P and Q both are true propositions. So P implies Q refers if 12 is an even number, then 12 is divisible by 2, which is a true proposition. Hence we can say that P implies Q is true if both P and Q are true. In case 2, we consider P is true but Q is false. These are the propositions. 7 is a prime number and 7 is divisible by 2. Here P proposition is true and Q is false. So P implies Q means if 7 is a prime number, then it is divisible by 2, which is a false proposition. So P implies Q is false if P is true and Q is false. In case 3, we consider P is false and Q is true. Suppose P is 3 is an even number, which is a false proposition, and Q is even numbers are multiplication of 2, which is a true proposition. So P implies Q means if 3 is an even number, then even numbers are multiplication of 2, which is a true proposition. So we can say that P implies Q is true if P is false and Q is true. In the fourth case, we consider both P and Q are false. For example, P is 13 is an even number, which is false, and 13 is divisible by 2, which is also false. So P implies Q is given by, this is a mistake, it should be implies. If 13 is an even number, then 13 is divisible by 2, which is a true proposition. So P implies Q is true if P and Q both are false. So we can say that P implies Q is false if P is true and Q is false. Otherwise, this is true. In the truth table, we can see here this P implies Q is false only if P is true and Q is false. Otherwise, this is true. This is another method to find the truth table of implication logic. P implies Q is equivalent to negation of P or Q. So if P is given, we can easily find out the negation of P. If P is true, negation of P is false. If P is false, negation of P is true. Now find out negation of P or Q. As we discussed in previous slides, this OR means the addition. So negation of P and Q, 0 plus 1 is 1, resultant is true. 0 plus 0, 0, resultant is false. 1 plus 1 is 1, resultant is true. 1 plus 0 is 1, resultant is true. Here we can see that this P implies Q is false if and only if P is true and Q is false. The next is by implication. If two propositions P and Q are joined with the connective by implication, then the proposition form is called a logical by implication and is denoted by P by implication Q. And it is read as P if and only if Q. Means the validity of P depends upon Q. Let's take the four cases. In the first case, we consider P and Q are true. P is the proposition 12 is an even number, which is a 2 proposition, and Q is even numbers are divisible by 2. Both propositions are true. So their by implication logic is given by 12 is an even number if and only if it is divisible by 2, which is a true proposition. So the by implication of P and Q is true if both P and Q are true. In case 2, P is true but Q is false. Here we consider 7 is a prime number, which is true. 7 is divisible by 2, which is false. So by implication of P and Q is 7 is a prime number if and only if it is divisible by 2, which is a false proposition. Thus we can say that the by implication of P and Q is false if P is true and Q is false. In the third case, we consider P is false but Q is true. Here we have considered 3 is an even number, which is a false proposition. Even numbers are multiplication of 2 is a true proposition. So their by implication is 3 is an even number if and only if even numbers are multiplication of 2, which is a false proposition. So we can conclude that the by implication of P and Q is false if P is false and Q is true. In the fourth case, we have considered both P and Q are false. As 13 is an even number, which is a false proposition, and 13 is divisible by 2, also false proposition. So their by implication is 13 is an even number if and only if 13 is divisible by 2 is a true proposition. So the by implication of P and Q is true if both P and Q are false. Thus we can conclude that the by implication of P and Q is true if either P and Q are true or false. This is the truth table of by implication logic. The by implication of P and Q is true only if P and Q are either true or false. This is another method to find the by implication of P and Q. The by implication of P and Q is equivalent to P implies Q and Q implies P. So if P and Q is given, we know that P implies Q is false if the first proposition is true and second one is false. So these are the resultant values of P implies Q. Similarly, we can find out Q implies P. When Q implies P means Q should be true and P should be false, then its value will be false. Now find out the P implies Q and Q implies P. Here this symbol and means the multiplication. Multiply these two columns. 1 times 1 is 1 means true. 0 times 1 is 0 means false. 1 times 0 is 0 means false. 1 times 1 is 1, that is true. Thanks for watching the video.